Recording has commenced.
Well, welcome this to the October 27th, 2020 session of Tangerine SDR and H, Ham, S, Ham Sci development, board development for the Personal Space Weather Station. My name is Dave, KB0S. And this week, I had an interaction, well, last weekend with Bill, and I've been able to compile most all of his code. I've still got a little bit more to getting Flask running correctly, but I was able to discover Red Bataya's Metis Atlas board sets, Hermes, and IQ2s. So they all show up in the discovery. Then I got out my discovery code for the, I have these command line programmers for OpenHPSDR. And I got out those and they discovered all those. And then I'm trying to make a composite discovery library out of code that I have in each of those different sets. Unfortunately, it's in Go, but it compiles to all these platforms, including the Pis. And I think it should all work fine, but I have to test it. So that's what I did for this week. Other than what you heard me talking about, working on papers and editing books. Okay, next on the list is Nathaniel. W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Things are going fine here in Scranton. Just continuing through the semester teaching. Let's see, been working with Dev on trying to get him going on doing analysis of some of the festival frequency type of measurements or Doppler shift measurements using the ray tracing software. So he's been doing that. We're looking at buying a new computer that's a bit more powerful to try and improve the situation with the passive ionosonde receiver. And I think those are the main topics right now. So W2NF, back to net.
Fine business. And next on the list is Dave, KD0EAG. Go ahead, Dave.
Hello. I have been moving very slowly on things, kind of it's taking me longer to get back into action than I expected after some medical things, but I'm slowly getting there. I really appreciated getting a couple of the magnetometer boards that were checked out by Dave McGaugh back. I now have them, and I can compare amongst them the good ones and the many others that I have to get them all sorted out. I thought I'd get some of that done today, but I decided I absolutely had to go out to the grocery store, and it kind of took up my afternoon. But otherwise, I haven't been doing a lot of code, software or hardware, really. Been mostly just vegetating, but I'll get back there soon, I think.
Very That's good, Dave, and hope you get well soon. And next on the list is Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Good evening to you and good evening to the net. Been working steadily along here. I added a time display to all of the pages of the Tangerine SDR user interface, so you can see the time in GMT as it ticks the seconds down. And I also added a feature so that I can display not only the FT8 spots that it has discovered by band, but also all the whisper spots that is discovered by band. So I enlarged the block over on the right-hand side that shows that. I've been going down through adding additional logging to the program and working my way down through my bug list. I have 136 items on the bug list. about half of the items I have knocked off of there. So I still have quite a few yet to go down and get. So also I've been working on a use case scenario for the data engine to localhost protocol. And when we get into open discussion, I'd like to go through a presentation that I have to get the group's feedback on my concept for the communication between the data engine and the local host. So that's what I have for tonight. Back to Ned.
Fine business. Very good. Got half the list done, sounds like. Next on the list, we have Dan, N4XWE. Go ahead, Dan.
Thank you, Dave, and hello, everyone. Well, I've been kind of busy. I started back to work, so it's taken up a lot of my days. I haven't really had a full day off since up until today. And I've got tomorrow off, so I'll probably be doing some work on software tomorrow. A couple of things. One of them I should have mentioned last week, and I didn't. The CM4 version of the Raspberry Pi is out, and I don't think they're very available yet, but they should be within a reasonable amount of time. And there's also kind of like a breakout interface board that goes along with this little CM, or CM stands for compute module. The other thing I should have mentioned and didn't is that Ubuntu 20.10 is now out. And that has very good support for the Raspberry Pi. In fact, the release of that particular edition is geared toward the Raspberry Pi by the Canonical Foundation. So they are making it, it's not the Mate or Mate version of it, it is the full 2010 version. So it seems to work very well. I actually got it up, got it installed. It runs fine. I'm using the 64-bit version. There is also a 32-bit version of it, and it is now available for download. And it is not the beta, it is the actual release. Anyway, that's about it from here. Back to you, Dave.
Sounds very good. I'll have to try that. And next on the list, we have Dave McGaw, N1HAC. Go ahead, Dave.
Yeah, good evening, everyone. Not a lot done on Tangerine. Been doing work, shall we say. Getting some things ready to go out in the field. We also have some material coming back from South Pole, which was finally nice to hear. Some of it's been 2 years finding it. Yeah, I hope the mag boards that I got over to Dave will help him move ahead on debugging some of the other cards. So back to Net.
Fine business. And let's see, next on the list, we have Dev. Go ahead.
Hello, good evening, everyone. So we had a good start of our new week here in Scranton. As Nathaniel said a while ago, I've been trying to model the Doppler shift observations made by Steve at his station in Texas. So I'm trying to model those through ray tracing, and we're trying to understand few of more nuanced observations there. And also we're making some slow but steady progress on detecting chop sound draw observations at the receiver that we have built here at Scranton. But we're trying to run that in a quasi-real real time. For that, it is appearing that it would require a larger memory than the current computer system I have has. So we're in the process of taking a new computer. So I think things are going along a certain direction, but with a slow pace. Thank you.
Yes. Well, thank you, Dev. And next on the list, let's see, we have Dick Patchy. Go ahead.
Okay, thank you, Dave. I hope you can copy me on my low microphone here. I did order a NVIDIA Jetson 2G with the power supply for $63. It hasn't come here yet, but I'm sort of interested in what the GPU stuff does. I don't really know what I'm doing with it, but I did order it. Back to you, Dave. Over.
Fine business. I have the older one that was about $100, and it seems to work very well with things that we've tested. I don't know if Dave has tried the newer one, but he has several Jetsons, and so you might bring that up later. Next on the list is Gary A58A, AF88, sorry, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Now you understand why I tend to operate CW with that call sign. Not just copying the mail and looking forward to the open discussion. Back to net.
Fine business. Sorry about that. Next on the list is James, KG4DSG. Go ahead, James.
Yeah, you got me?
Yep.
Just checking in and listening. One small comment about the earlier announcement of the Compute Module 4. I found a video out on YouTube talking about it. One of the interesting features is it's got a full PCIe by one lane on the module that can be brought out to a breakout board. They're looking at it for storage capability, but that's a lot of bandwidth on a little chip. So for that, back to the net.
Yes, I was looking at that and thinking about possibilities of what could be plugged into that. Anyway, next on the list is Jonathan Rizzo, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It has been a busy week of homework and schoolwork and work. But October 24th, there was a transmission from the Brampton radio station in Sweden. With the call letters SAQ, and it was transmitted on 17.2 kilohertz CW. And the carrier was driven completely on a very large generator for those who know about it. So far, a lot of good reception reports. In Europe, of course, there were a couple good reception reports in the US as well. So that would be another great reason for the VLF module. People could record the transmissions and decode them later. Other than that, that's all I have. Back to the net.
Fine business. And let's see where looks like Michael AA8K. Go ahead, Michael.
Well, thanks, Dave. Greetings to everyone on the conference, and back to you, Dave.
Fine business. And next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Okay. Did this change? Was my call sign usually on there and it's not on there now?
Yes, it's got your email address now.
Oh, that's weird. I didn't do anything here, so go figure.
Yeah.
Anyway, lots of things going on this week. Before I forget, make sure to mention about our time change next week, right, Dave?
Yes, that's correct.
Okay. I wanted to make sure it was next week. And I even went online and checked, and it is November 1 that we changed. So So oddly enough, the one state where the time change does not change, Arizona, it'll be at a different time. And this week, so there you go.
But
anyway,
we do keep. We're going to be 2 GMT.
Right. So you're going to change the meeting time for me who never changes my time so that I get to change my time.
Yes.
You're feeling, I'm feeling left out, right? So you're just trying to help. Okay, it's not working. Anyway, this week, the updated Magneto Pi hats, blank boards came into the CM, and we got the parts in on Friday. The new turned around with the tab basic up Ethernet connectors. So they're being assembled right now. I think I will have all of them by the end of the week, is what they're telling me. So then the pressure will be on me to do all the testing and make sure that they all work. But that project is going to be coming to an end pretty quick, and we'll be sending those out to the lucky recipients to have some fun with. Data engine, been working some on that also. I got the clocks all connected up and figured out. So I'm down to just some IOs left and a couple parts that I have to finish integrating. And then it's going to be a whole lot of checking because it's a pretty complex board, and we got to make sure we don't make a mistake like I made on the Magneto board with part being built wrong. And also, actually, today I've been working on a PSR article for the Magneto Pi. So that's going to be coming out probably next week, I would guess, maybe the week after. So I'm writing that up, and I got some pictures, and I got a block diagram, which actually I can show you guys tonight if we get into the free-for-all. And Nathaniel, I'll make sure I put in the grant numbers and all that so that we get some visibility there. Also been working with Tom and John a little bit on the clock module. Looks like John is making great progress on that. And we got the pinout pretty much nailed down, and plus or minus his final version. So and he's on, I think, let's see, it was Mondays today. Yeah, was on the road today, back from his UP place back down to Ohio. So, but made a lot of progress there, and I think that he has a little bit more to go than he thinks that he does. He thinks he's mostly done with the schematic, but I think there's still a lot to do there. But it's coming together, I think. So there's between Tom and John, mostly Tom and John, not so much me, but they've been going back and forth and figuring out any problems and fixing them. So let's see. Okay. Also discussed a little bit with Tom and John about the A to Ds for the VLF module, and I wanted to bring that up later on in the discussion. I want to talk to Jonathan about it, because I read through the data sheet and it seems to me there might be a problem with what the performance that we think we're going to get out of it. So this makes it all the more important to maybe get a development board and test it, because I don't think we're going to get the performance that we want out of that part. I hope that I'm wrong, but it doesn't, I don't know. So we need to look at it. I guess that's about it for this week. So back over to you, Dave.
Well, fine business. And next on the list is Tom McDermott. Go ahead.
Hey, good evening, Dave, and everyone in the group. Been an interesting week. A lot of activities not necessarily related to this project. Put in a code tweak for the OpenHB SDR in a radio code to turn on a mercury control bit. That should harken back quite a ways in terms of modules. Anyway, it turns out Red Pitaya uses that bit. And so I got a request, and I did a quick test load, but it didn't seem to resolve this particular gentleman's issue. And a lot of emails with John and Scotty on various modules. And I think we'll get into that later on in the discussion tonight. Back to group.
Well, let's see. I think I've called on everybody, so we should be open for general discussion.
Okay, you want to take, let me show you the block diagram of the magnetometer that I drew up here. Hold on a second. Got to get it open first. You know, when you have so many projects all on your computer at the same time, it becomes a nightmare to try and figure out where everything went. Let's see. So this was magnetometer block diagram, right? There it is. Okay, here we go. This will be, okay, now I can share the screen. So this looks like what a system would look like if you were to plug two boards together, and removing the stuff that is not really used on either end. So even though the two boards, the board at the local site and the board at the remote site are the same board, pieces are not used when you don't have the Raspberry Pi present and when you change the straps and things like that. So this is kind of the way it will look if you put one out in your garden and you have one on your Raspberry Pi plugged in inside. So the Pi plugs in here, and you've got the serial ID prom and the socket, which will be empty, and the temp sensor, and then the bus extender. And then the regulator gets its power off the 5 volts and supplies power to these guys off of that regulator, not to the top one, but these three guys. And then on the other end, since you have no Pi, that basically that connector goes away. The serial ID prom goes away. It's not used for anything. The remote module plugs in here. The RM3100 plugs in here, and the power comes off of the cable and supplies these three boards. And this shows the data ready output coming back over the cable into the Raspberry Pi. So you actually have two data ready interrupt pins. One if you're using it local, which will normally not be used, and one if you're using it remote, which would be the one that you would use if you have one out at the other end of the cable. So that's what's going to appear in the PSR. So did you fall off your chair, Dave? Anyway, so that's what's going to appear in the PSR. I think that's pretty much, unless someone sees a mistake in it.
Looks good here.
So kind of the simplified view so that you know, leaving out all the details and options and all that stuff. Just, okay, two boards, magnetometer one end, Raspberry Pi on the other. This is how they talk. So simplified.
Yep. That's great, Scotty.
Now you have Cat5 up to 100 meters. It's making use of a super low dropout 3.3 at the far end. Is that what it was?
Right. And actually, it'll be more than 100 meters if you want to change the resistor on the board and use two wires in the cable for 5 volts. We already used two wires for ground. So, but the calculations that I did with the regulator dropout give me about 350 feet, 360 feet.
Yeah, that's good.
So I think we're good. If you need more than that, the problem is that you probably will run out of I2C length before you run out of power. Because I haven't done the calculation on the capacitance, but as you add capacitance to the output of that cable, then you skew the data and the clock, and it doesn't like it. So,
well, it's really not the capacitance; it's the propagation delay. It is a delay line.
Yeah.
Transmission line rather than straight capacitance.
Yeah. So that was this afternoon's task, drawing this up. So got that done. So I haven't heard back whether this is a good enough resolution for the magazine yet, but I think it will be. I can blow it up bigger if need be. So that is all on that.
Looks good.
Tom, I had a question about your correction on the Metis board.
Yeah, it wasn't really a correction. The one fellow wanted a particular bit called the Mercury Common Clock bit set, and there's no registers to control that. So I just did a quick load, which forced the bit to a 1.
I was wondering if we, the reason I was thinking about this is working on the programmer this weekend. I was wondering if we want to have a document similar to Metis how it works and the USB document that specifies data packets. Well, at least the one I'm interested right now is a discovery packet. And should we be thinking about starting to write that?
In my view, it's never too early to start on documentation, but I think I'm in the minority in the engineering community.
Well, I'm trying to stir up a little interest in, because it's not clearly just a clone of HPSDR protocol, although we want to be compatible. And then, so, but in some sense, we have to have some packet that you send a broadcast and it will reply that here I am and what information we want to send back.
Right.
And we ought to at least think of that packet first. And if we want to, we can either use the VITA 49.1 or the Open HPSDR or some other sequencing kinds of things. But it's kind of hard to write code without having that written down. This is the way we plan to do it.
Yeah, and I agree with you, Dave. And I would like to, I started doing that a long time ago, even before Hamcation last year. And I think, did I share that with you, Bill? Or I was supposed to, and I probably didn't because lots of things didn't happen back then. But it definitely needs to be written down so that we can code to it, or at least at the same time as the coding happens so that other people can code to it.
Yeah.
Well, which protocol are you talking about?
We're talking about the UDP protocol, but Dave's talking about the very beginning commands that are like erase memory, erase sector, and
things on the Tangerine.
Yeah, like for, I mean, but I think you're talking about mostly the sequence you have to go through to upload firmware into it.
Yes. But also it could be sending data, you know, different ways of asking for data.
Yeah, the current Open HPSDR discovery process has a couple pretty significant limitations.
Yes.
You may want to kind of augment around.
Yes, we need to fix those.
Yes.
And we need to write down how we fix them.
Yeah.
Yes.
Yeah, so I had to code around a couple of those in writing the driver. So anyway, we can talk about that later.
So my suggestion is that we start some sort of a document, but I don't have a clear vision of should we use a HPSDR format, or should we use some other format, or should we make up a new one, or what?
Well, I think what you're talking about is perhaps what I have a presentation prepared for tonight.
Okay. Well, then I guess I trumped.
Yeah, that was the document you were talking about, Bill, that you were going to, you kept asking me, when am I going to need it, right? That's that document, right?
What I have, well, I thought what I'd do, I have the document largely written, but I thought before I spend another 40 hours on it, I would run past this team, at least the bones of it, because if I'm missing some major things, it's better to find out about it before I spend another 40 hours writing the document. And
I'm a little skeptical of other than for informational purposes, designing something by team is going to be really hard. It's more what
I want to do is I want to show the team what I have designed, and then we can go from there.
Okay.
So you're going to do that tonight, or you going to do that?
Yeah, I've got it prepared. If I can share my screen here. Let me see. Okay, I got to first put this thing into slideshow. didn't work. Try it again. Okay, I think this is what I want to do here. All right, you see a presentation there showing on the upper left, it says Discovery.
Yes.
All right. On the left is a data engine, and on the right is a local host. When you first turn the data engine on, it starts listening on port 1024 for a discovery packet, which we would say, that would be the same as the discovery packet used today, where EFFE to begin with, and then you've got your status MAC address, version, and board type. And for board type, I took the next available number, which is a 7. I think the existing devices go up through 6. And then you fill this whole thing with, for a total of 60 bytes. That's what you send. And when the local host sends that out as a discovery, and then this is the reply. So you get that back, and you find out from the data engine what his IP address is and what port he's listening on for port B. So this is what we call the provisioning pair, port A and port B. And Scotty, this is, I've been trying to be as faithful to the discussions that you and I had during Hamcation as possibly can.
Okay.
All right, so that is our first, that's initial discovery. Now, the next thing that happens is the create channel. So the local host sends out a create channel packet, which is, and I'm going with, in this plan, going with all human readable things. So this is a command, which is just literally the bytes CC, a space, and then a port C and port F. What we're doing is, this is a local host telling the data engine what ports it's going to listen on. It's telling the local host port C and port F. And what I'm trying to do is make the bulk of this simple enough that you could control this thing just using a terminal emulator. So you could key this in. Now, we'd have to figure out something different for the initial discovery, but if you're doing a discovery manually, hooking up to it manually, you're going to know what the IP address is, and you just have to know what port you want to talk to. So, assuming we get the data engine is able to accommodate the request to create this port, or rather create the channel, it's going to send back a reply, an acknowledgement, telling the local host what ports it's going to listen to. So listen on port D and E. I think there might be something missing here. I think I've got to specify the create channel number. Yeah, I think there's supposed to be a channel number in here, a 0. So let's say we create the first channel, we call it channel 0. That would be in here.
So Bill, then you're using the provisioning ports A and B to tell the data engine, actually the data engine tells the local host tells the data engine that it wants to set up a communications channel, right?
Yes.
Is that what you're setting up now?
Yes.
Okay.
So in this exchange, the local host tells it, I want to create channel number 0, and we're going to use ports C and F for that channel for the local host to listen on. When the data engine says, all right, we can do that, here's an acknowledgement. I'm going to tell you for that channel what my ports D and E are. These are the ports that the data engine is going to listen on. So it's telling it in so many words which ports it's going to listen on. So those is the configuration port and the data port.
So this would be equivalent to like when we discussed it at Hamcation. That would be like my command channel and the stream then, right? So one is for data and one is for modifying the data, modifying the stream.
Yes, right.
Awesome.
So here's an example. Again, I think perhaps I need to rate. Well, it's going to port B. So I don't have to mention the channel number in here because port B is associated with channel 0 now. So, but anyway, I send it from the local host Okay, data engine, here I want to create this channel, and I'm going to listen on ports 40,002 and 40,004. That's ports C and F. And the data engine says, fine, wouldn't do that. I'm going to listen on ports 50,001 and 50,002. And as I said, this is our configuration pair, and this is our data pair. Now,
and that the request to establish that pair comes in over the provisioning port.
Yes.
Ports A and B.
Yes, yes.
Okay.
All right, so now we've got a channel. Now we're going to configure that channel. The local host sends the CH command to port D. And he's listening on port C for a response to find out if this is okay. What's in that? Well, it's got CH, then a space, then a channel number, then a space, then which standard we're going to run. VITA 49 or VITA T. Then a subchannel count. How many subchannels are you going to want within this channel? And then anywhere from 1 to 16 subchannel definitions. Again, these are space delimited, ending with a binary 0. So it's a string which you can work with very nicely in C or Python.
So are these channels all interleaved, or does that depend upon their definition?
I'm going to come to that.
Okay.
I'm going to come to that. Okay, each subchannel definition has a subchannel number, the antenna port, that's port 0 or 1, and what is the send frequency in megahertz. That's a subchannel definition. So here's an example. This is what the local host sends from port C to port D to configure this channel. It's channel 0. We're going to operate in VITA 49 format. There are 5. This is a count. There are 5 subchannels that I'm going to want. They're all going to run at 4,000 samples per second. Number of subchannels. There's your data rate. Now, there's a subchannel definition. That's subchannel 0. It's going to run antenna port 0, and 3.573 megahertz is the center of that channel. Subchannel, and each of the subchannel definitions is the same. It's like that. So there's one for 40 meters, 20, 15, and 10. So now, when we get ready to start data acquisition, I just send a start channel command to port D, and now spectrum data starts going from port E to port F. Now it doesn't, I'm not caring once I start getting this data at a port F, I don't care which port it came from. Port E is a future thing. It's going to listen in the future when we want a transmitter over here. Port E will be where we send microphone data in the future. But right now, port E, you can send from it or you can just leave it dormant. So the start data acquisition is nothing but SC, space, and then a channel number that you want to start. In this case, it would be channel 0. Now let's say that we want to provision a second channel. Well, okay, there's your example. Let's say we want to create...
Bill, didn't you already provision that when you established the 5 channels on the...
No, those are sub-channels.
Oh, okay. Okay, sorry.
So we created one channel with 5 sub-channels. That's what we've done so far. Now we're going to create an additional channel because, why would you do that? Because this allows us to run different channels at different data rates, and it allows us to run the different channels at different data standards. So once again, we send a CC, which includes ports C sub 1 and F sub 1. That should be a subscript on that. So it's going to acknowledge port D sub 1 and E sub 1. So now we've got channel 0 using this set of ports with data going to port F0 here, and channel 1. And we've got 2 channels of spectrum data going. And this is what I've implemented in the simulator and local host, and it works like a champ. I've run it as much as 3 channels with multiple sub-channels within the channels. Now let's take a look at what the spectrum data looks like. Each data type gets its own channel in the case of Vita 49. So this is how we would do FT8. FT8 and Whisper. FT8 on channel 1, Whisper on channel 2, say. Each one gets its own channel.
And now you're talking channels, not sub-channels, right?
Correct.
Okay.
Correct. Because FT8 and Whisper each can have multiple sub-channels. So on the FT8 channel, we can run 8 sub-channels of FT8, and on the Whisper channel, we can run 8 sub-channels of Whisper. And you could make it more, except, you know, you don't have that many antenna ports. If you're going to run more than 8 bands, you're going to have more than 2 antennas. But nevertheless.
But so like the idea is then all the Whisper data has got the same format and the same sample rate. So put them all on sub-channels and you get them all at the same time.
That's the same, right. The same thing with FT8. You have to run them all at the same speed.
But they could be on different bands.
Yeah, absolutely. Each sub-channel can be on its own band, and each sub-channel can have its own antenna port too. So you get to specify that. And in the case of Vita 49, each sub-channel has its own stream. And the streams are interleaving. I'm going to get into more detail on that in a moment. But this is Vita 49. This is the official ANSI standard. These are bits here. These are 32 bits. Now, we're not using all of this. We don't need the fractional seconds. We're not going to work with fractional seconds. This class identifier, I don't know whether we need this or not. It's got some useful things you can do with it to identify things, but and then the data payload is always going to be 1024 samples of IQ data, each being 32-bit floating point.
So Bill, how do you identify whether these optional fields are present or not?
There's a 2-page discussion of that, but basically you have to look at how this header is broken out.
Okay.
That's probably beyond the scope of tonight's discussion, but the bits here tell you whether these items are present or not.
Okay.
And once we finalize this, that's probably not going to change very much, because these things, they have their uses, and once we decide what they are, we can decide what we're going to keep and what we're going to throw away. But in most cases, well, all of the applications that I've been able to figure out, we're going to use integer seconds.
Bill, if you pardon me, we don't seem to be getting your mouse mic. We're getting a computer mic.
That happened again. Hang on a second. I'm sorry. Somebody should have said something earlier. Hang on a second. Is that any better?
Nope. It's actually pretty good audio, but yeah, you're right, Dave. It's echoing. So it's like coming off of the computer or something instead of the boom mic.
Okay. Okay, microphone Realtek audio. That's about the best I can do. This is a classic problem. The camera and the microphone are fighting for which one is the audio feed to Zoom, and I don't know any way in Zoom to
it's like
force
the camera one.
Yeah, I don't know any way in Zoom to force it to take a particular microphone as input. But are you able to understand me well enough that we can get through I only have one more slide.
Yeah, which is good.
Yes. Yeah, it's audible.
All right. This shows a comparison of Vita 49 and Vita T. On the left, you see Vita 49 that we use for FT8 and Whisper. This is optimized for decoding. In this case, the streams travel on a channel and they're multiplexed. So there would be a packet. Let's say we had 2 sub-channels. There would be a packet of 1024 samples to sub-channel 1, and then you'd get the next packet it would be subchannel 2, and the packets alternate between the subchannels. That is VITA 49 compliant.
So not samples interleaved, but packets interleaved.
Right. That's what we use for FT8 and Whisper, because that works. What I'm trying to do is I'm trying to minimize the processing and data manipulation we have to do on the Raspberry Pi, because it's not a very powerful device.
Right.
But with this works very cool, because you just count these up and you write them into a file and then pass it to the FT8 or Whisper decoder and you're done. Everything else happens automatically. Now over on the right, you see the VITA T, which is optimized for DRF, digital RF. In this case, all the channels come, all the packets in this case are coming from a single channel, but the IQ samples are multiplexed within the packet. So here's subchannel 1 sample 1, subchannel 2 sample 1, subchannel 3 sample 1. Actually, that should be subchannel 2. Yeah, subchannel 3 sample 1, and subchannel 1 sample 1. That should be subchannel 3 sample. Well, however it goes, it'll alternate between the subchannels. Oh yeah, this is right then. This is assuming in this case you have 3 subchannels running. Subchannel 1 sample 1, subchannel 2 sample 1, subchannel 3 sample 1. Now you get into the next sample of subchannel 1. So in this case, it's round robin of 3, assuming you've got 3 channels running.
So you're numbering the channels from 0, but the subchannels from 1, or is that just an incident?
Just an incidental. I mean,
okay. It'll be 0 through N, right?
Yeah, I mean, we can number the channels any way you like,
okay.
But it just seems simplest to start with 0 and work up.
Yeah.
So when we're creating the channels, I do it very simple in the local host. I do 3 create channels, 0, 1, and 2. And then now that I got 3 channels established, I send a channel configuration command to each of them. So here's the subchannel layout for 0, the one for 1, and the one for 2. And when I do the subchannel, when I set the channel, I'm telling it which VITA format it's going to conform to and what the data rate is.
The only question I asked is because you start with subchannel 1 instead of 0. That was the.
Oh yeah, I mean it could be subchannel. The numbering is not meant to be significant here.
Okay.
So now, I studied a little bit on these HPSDR protocol 1 and 2, and protocol 2 is, I'm not sure all of the design criteria the designers are trying to, I mean, they even have some, what would you say, some dynamic requirements on the frequency, like you have to send a heartbeat every 100 milliseconds or something, and
yes.
I'm not sure why you need that, but
well, some of these features were put in because they had problems and they were to address these problems.
Yes.
One of them was the source going away and if the transmitter's in transmit, so you end up still transmitting even though the radio is disconnected from the source. And so they put this heartbeat thing in to make sure it gets disconnected quickly when the data gets lost.
And the other thing is one of the loudest pieces of the clientele were fast CW operators. And they wanted very tight coupling between their keying and it going out over the radio.
Yeah, and the way we did that is we did remote, or I don't know, local CW or whatever, I don't know what Phil calls it, but we do the same thing in the IQ2, whereas the key is hooked to the hardware and the key down command does not go over the Ethernet and the key up command does not go over the Ethernet. Well, actually, I take that back. The key up and down commands do, but the RF does not. So you're not generating the RF with data packets going over the. What you do is you say center frequency here, generate an envelope on, and that way you don't have to continually send data to produce the sine wave that you want that's a CW keying. And they build the keying wave shape into the radio and all that. So that's kind of a workaround. But I mean, we can do that because this will be just a different packet type. right?
Yes.
Yeah, I mean, if you want to run it that fast, you also have the option of hooking the hooking your paddle up to the hardware I/O port on the data engine itself. Let's get the all the delay and all the mess of the Ethernet out of it completely.
And that's what we do with the IQ2. When you key the thing down, the FPGA generates the CW, generates the waveform. So the Ethernet isn't involved. And then actually, interestingly enough, you can hear the waveform in the receiver, you know, if you're full duplex. But then you get the receiver delay there. So then you have to generate your own side tone locally because the receiver delay is enough to just confuse the heck out of you.
Oh, yeah, yeah. If you hear something that you're generating delayed, it'll completely scramble your brain.
That's right. So.
We had one of my buddies does a thing for, there's some group up in Canada that raises money for providing toys to disabled children or something. And they have this desert bus thing where they raise money, and they've got this. It's like a telethon that goes on for a whole week, and this group of geeks has to do something to keep people entertained for a whole week, all 24 hours a day. And so one of the things they developed was a speech jammer, where you wear a headset like we wear here, but then they would take your voice and feed it back into your headphones, delayed by about a quarter of a second. And it is almost impossible even to talk when you've got that going on. But anyway, so this protocol that I have just described, I have this written in excruciating detail. All I have to do is put the ribbons on it. If you guys like it, okay, well enough. I mean, if we want to do something more sophisticated for future, and we want to look at HPSDR2, we might want to put that to version phase 2 or something, because
well, what I'm thinking is that this is just going to be the beginning of what we're going to add to. So I mean, this has got to satisfy the PSWS functions and the Whisper functions and the FT8 functions that you've already developed. But then when we want to add direct CW or want to add, for instance, what I want to add is I want to talk about streams that you can create to different IP addresses. Okay, so I want to be able to, as the local host, I want to be able to tell the data engine, originate a stream to that box over there. Or I want the box over there to be able to come in and say, hey, give me some data. Whichever.
Well, this protocol supports that.
And you haven't mentioned it, but suppose I have multiple data engines on the same network and I do a discovery. Is that kind of scenario supported where I do a discovery and I get 3 replies back?
Yeah, we've already got that working. Dave you got about half a dozen devices to reply back to the discovery packet.
Yes.
The only thing I have to add to the local host is something to give the user a choice on which data engine to pick to connect to.
Yeah, because right now Protocol 2 just says the last one in is the one that gets it. So there's not really any way to maintain 3 pipes, so to speak.
Well, this will maintain as many pipes as you have bandwidth for, because I'm keeping track of the IP address and all the different ports for all the different channel pairs independently for each device. Okay,
so that means if we had a different client, say, on the network, and he could actually do a discovery himself and get an additional discovery back to him. He could open his own channels directly with the data engine to a completely different IP address.
Yeah, you could put 2 local hosts out there, and this thing will handle that.
Okay, Bill, are the different local hosts and the different target radios all distinguished only by Ethernet MAC address?
Well, IP and port, I mean, mainly the IP address is how we distinguish them. I mean, that's just to begin with. Nobody said they want anything else. So
yeah, you mentioned in your discovery the Ethernet MAC address, but nothing about IP addresses or other things. Well, do you basically send UDP packets?
The IP address comes back in the header of the packet. So I don't use that MAC address for anything. It's there because it's in the protocol.
Right. One of the problems that we ran into on Protocol 1 is if you had several different radios, the only way on protocol 1 you could tell which was to say, do I know the MAC addresses of all the radios I have out there? And can I select based upon a particular MAC address? So you've obviously, from a discovery point of view, do you just look for all discovery replies coming from everybody and then line up their MAC?
Yes, that's the way it works.
Okay.
And so they do reply with a MAC address, and the MAC addresses are unique. There are times when the IP addresses can be confounded, but generally not.
But the thing is that you could get the same port address on 2 different machines, but you're never going to get the same IP or MAC address with the same ports at the same time.
I mean,
right.
If we have to maintain a table of IP and MAC address, we can. As of right now, I'm not supporting that, but I hadn't run across a situation. What causes the IP addresses become confounded, Dave?
Well, it's when people were dealing with these, at least in the Open HPSDR, we had several different kinds of IP address spaces. And I think that's where we had problems, but I remember we had to
the PIPA address. Some machines didn't have a DHCP server, so they would use the PIPA address and not a standard IP address.
Yeah, there was another issue that arose in protocol 1. The discovery is an Ethernet packet and just sent to the broadcast address. That means you can only discover radios on the same subnetwork.
Correct.
Right. So there was no way to send a UDP packet to discover a radio on a different subnetwork.
However, with this protocol, you could theoretically, if you knew what the other radio's address was, you as the local host could direct the data engine to send the packet to wherever you wanted.
Right. So that's a difference in that the discovery packet in this case is a UDP packet, not an Ethernet frame.
But how do you discover radios then? Because isn't a UDP packet?
Because if you know the IP address that you want, then you can you can
so
hardwire the IP address.
It wouldn't do a worldwide broadcast, which is not a good idea.
Well, you can't do it anyway. No routers on the internet is going to let you do it.
Well, right.
But you could do it over a larger subnet space.
Yes.
A broadcast or?
Yeah, but you don't really want to do that. What I would say is you want to look at your local 256 numbers. And then if you knew a specific number somewhere, you could actually do what Tom said, is put the number in.
Yeah, but you're going to have to know the exact IP address because routers will block you from sending to a broadcast.
Right.
Right. So you can do a broadcast to determine a radios on your local net, or you could do a broadcast Ethernet packet to a specific address that then will get you a response if you pick the right address.
Right. So if you're doing all of the protocol discovery, everything in a UDP packet, I think you avoid a bunch of these issues.
Yeah, and you could actually even do something like Kiwi SDR does, where you maintain a server of people who allow access to their board.
Yeah,
that's precisely the point.
Flex Radio does that. Yeah.
Good.
And basically, you consult the table of clients that you might, or servers rather, and then you can just go out and discover them with a direct packet.
Right. Yeah. So the reason that happens maybe on large campus networks, the network may not be one large subnet, but maybe in fact broken up into different subnets with routers in between them. And by using an IP address, you can avoid problems trying to discover radios that are on some other side of a router.
Yes.
That's kind of an advanced topic. I hope we don't have to solve that for phase one, but point taken though, to be able to have that kind of flexibility can get you some, can buy you some things.
So Bill, this is really nice. I think it'll work. It
Yes.
seems to have a lot of potential. I have one question. How do you interact with something that might be either a USB or an IQ squared? Would it have to go through the data engine to those, or would it have a different process to talk? For example, the magnetometer.
Well, the magnetometer, I'm thinking that the simplest way by far is to connect that to the Raspberry Pi.
Okay.
And now, having said that, I have defined a telemetry packet that, again, it's going to be human readable, space delimited, and so you can put, until you run out of space in a packet, you can put 8,000 bytes of miscellaneous stuff, however we decide to define what's in there at a minimum. You know, you're going to get the serial number of the various instruments on the that the data engine has access to, the temperature of it, and the voltage it sees, things like that. You know, if there's a need for us to carry a lot of data items like that, that concept can be expanded.
So the idea would write a network aware server program for each device, each kind of device.
It depends on what you want to do. I mean, if you want to just pick that data up in the local host and store it in digital RF or upload it to a server somehow is already interpreted. I mean, I think we're going to have a bunch of instruments out there. Case Western Reserve thinks of them, they call them nodes. And each node is going to be identified with an account, which is a user. And so what we want to do is have this data bubble up from going through a hierarchical structure, starting from the instrument to the local host, then up to the server.
Yeah, but all that will be handled through the provisioning port. If you want to query the device and say, well, what's your account and user node number, you know, that could be stored in the data engine or in the local host, but it will be associated with a particular set of channels, right? Or channels.
Well,
right?
what I'm trying to get, if this is communicating all that this weather station has available, that will be a piece of software on the local host that is talking to maybe a GPS for a location, and not for timing, but for a location, a magnetometer, and then radio packets that are coming out of this.
Yes, what I envision is that the local host is an instrument that has multiple sensors on it.
Okay.
And that's the hierarchy. And each one of those sensors has its own serial number, but they're known to the local host. Then you've got an army of local hosts, and they are known by their node number token to the central server. And I've already got a working protocol for how you upload spectrum data, about 5 different ways that can be pushed up to the central control system.
Okay.
And my students now are working on designing the database that's going to handle that stuff, and it's going to work very much like SatNogs in that the database tables contain the stuff that's appropriate to put in tables, like the users, their nodes, their instruments that they have, and then as they push data up, the data gets added as files, and then there's a cross-reference to those files put into the tables, so that you can index the data umpteen different ways by, by frequency, by time, by node, by phase of the moon, or whatever we decide however we want to, whatever metadata you want to associate with individual blocks of readings. And that's also going to be, the spectrum data is also going to be in digital RF format, which has its own block of metadata, which we're already handling, that it gets information out of the local host configuration, so that when I get a package of data coming from a node, I can take it apart and know a lot about it, even if I don't have the database at central database available, because it's self-documented. So
okay.
I'm sorry to monopolize this whole discussion, so but
it's something I wanted to know about.
But I will have a write-up on this. This write-up on this is about 80% completed. I just got to get it cleaned up and get all the, any omissions and mistakes out of it. Then I will circulate it.
Okay.
That was good.
I got one question.
James.
Got a question for Bill.
Go ahead, James.
The very first, one of the very first pages on the presentation talked about the actual initial discovery protocol that appeared to be triggered by the local host. Is that something that's going to be on the UI, or is that something that's going to be running in the background constantly?
Let's talk about that. It's a good question. The way I have it set up now is when you start the local host, it automatically does a discovery to find out what's on the wire. That's what happens, and it will actually update the user interface web page to show you what it's found, that it's got a connection. If you lose connection to the data engine, or you start the local host before the data engine is turned on, there's a button you can click that does a restart. Or if some weird thing happens, the data engine hangs or whatever weird thing happens, we have a restart concept that does a cold start on the data engine, as though you just turned it on. Hopefully we can implement that.
But that means you can trigger the local host to send another discovery, correct?
Yeah, that's what it does. What it does is it sends a command to the data engine to do a cold start, and then it does a fresh. It waits so many milliseconds, and then it does another discovery.
But it doesn't necessarily dump the ones it has. It just does another discovery to perhaps add to the list if there are more. I hope that's true.
I have
right now.
Right now, I have a one-to-one relationship to data engine and local host. Whatever the local host is connected to, if it does a restart, it's going to just restart whatever it's connected to. And right now, I only have a concept of having a local host connected to one data engine at a time. But it knows them apart because they're on different IPs, and each one is distinct.
So in order to have the local host connect to multiple data engines, then you'll have to create a table with IP addresses and all that to track.
Yeah, I mean, that is not something that is important in phase one, but it's quite doable.
Yeah,
I mean, the machinery is there to do it.
I just want to make sure that it is, because I was told that this is going to be available in Protocol 2, and it isn't. So that's, and I mean, we talked about this, I think, already. So I'm sure you're keeping it in the back of your mind that this is something that I really want to be able to do in the future.
Yeah, I mean, we've got to beat the competition. You got to beat the competition. We've got to make sure that we can say that we've got this that they don't have. No, I understand that. That makes sense. I mean, Dave, you and I have had some discussions about how to approach this, since we're going to find both Tangerines and HPSDR devices on the wire.
Yes.
It's necessary to give the user a way to pick what they want to talk to.
Yeah.
Yes.
I think Dave, you and Dan are going to work on something that will adapt this to be able to use the data coming from the red Pataya when it's in HPSDR mode.
Well, I have
ahead.
code for discovery of both HPSDR protocol 1 and protocol 2. Right now they're in separate programs, and they follow, you know, it tells you everything it finds at one instant, but it doesn't do any continuous pinging kind of thing. But I have the bits and pieces that are necessary, at least for OpenHPSDR. And with the similarities in the discovery, there's really no difference between OpenHPSDR and this.
So
at the
one
discovery
question
level.
on that similarity is, I see you fill with zeros to a total of 60 bytes on the discovery. Did you ever find a reason why you needed to do that? Because Phil could never tell me why that was necessary.
I don't know.
He said
That's about
something
the
about
same
how
as what Phil told me.
well, he said he had read somewhere that that's the minimum packet size was.
I think that's what.
So in an Ethernet frame, 64 bytes is the minimum size Ethernet frame.
Yeah.
Where do you see that? Because I looked and I could not find where this was required.
Okay, on an Ethernet frame, I think that's NATO 2.3 spec on the minimum size.
Maybe it's because I'm thinking this is a broadcast that is not really an Ethernet frame and in HPSDR protocol, so
right.
it
So
would be required.
Yeah, so if it's UDP, you have 40 bytes of UDP data in there, and you'll easily fill up 64 bytes in the Ethernet frame.
Okay, because that frame includes the headers and all that, right?
Right. So yeah, the 40 bytes gives you the source and destination IPs and port numbers, and other stuff. And that has to then fit in an Ethernet frame, which then has a checksum that it adds, and it prepends it with Ethernet routing type and optionally VLAN information, other stuff.
It seems to me that's like 24 bytes. So then you end up with 40 bytes minimum of data size that you have to.
So you'll end up, it guarantees the Ethernet frame will have 64 bytes in it.
Okay.
At a minimum.
Something that might be useful. I don't know if we have any Wireshark people here that are good at wire. Huh?
Yeah.
I've used Wireshark before to track stuff.
No, I mean, Anna McDermott wrote an OpenHPSDR add-on to decode HPSDR packets.
Add-on to Wireshark?
Yes.
It was a dissector, and I was never able to get it to work.
I found another one online as well that was claimed they did it, but it might be nice to have somebody work on that if somebody knows how to do it.
How about Anna?
Possibly. We have to have the definitions hard, but it would be great to be able to run Wireshark and look at the packets going by.
Yeah, and have them all packetized and color coded and all that for HPSDR for Tangerine.
Well, I just use TCP dump to look at the packets on Linux, and that's
it doesn't do any formatting,
so
right? Does it do any formatting of decoding or anything?
Yeah.
No, I mean, you can get it to show you the ASCII equivalent of, but I mean, and that's useful for the stuff that I'm doing that's human readable. In fact, it did occur to me, I might want to even define an ultra simple discovery that uses only human readable stuff, so that you could control the data engine with just a terminal emulator and NC. You'd have to know the IP address, and then we send it a carriage return, and boom, it would come back and tell you something like, here's the number of the port I'm going to listen to. Then you're off to the races. You could send it a channel config or a create channel, and then you could, just using a terminal emulator, you could send the command to this thing, and someplace else you have something, that starts listening on the right. You can tell it where you want the packets to go. So start sending, so something just listening for packets. That's very similar to the way I'm doing the decoder. Well, all the receiving is done by separate C programs that get spawned off as independent processes.
Scotty, not to interrupt, we're short of time. We never
Yes.
got to the discussion of the VLF receiver A to D converter chip. Can we put that on the parking lot for next week?
Yeah, I think we should, because
Yeah, we do need to talk about that.
And if you want to, I can I can share the screen with the piece of the data sheet that I think is the problem, and let Jonathan go off and figure it out. Because
yeah, well, show me it too, just so you know. I'll put on my hat here as the applications engineer for Analog Devices.
Okay.
I was the senior engineer for these parts.
It's a serious
type
part,
of parts.
but you know the specs.
Oh, I know exactly what they are.
Okay, so let me get the data sheet up here.
No, I was
moment.
app engineer for the digital audio group.
Okay, here we go.
David, which company was that?
Analog Devices.
Oh, yeah, that's right.
Okay, so I'm looking through the data sheet and I'm going like, well, this looks really good. And then I get down to, let's see. Okay, get down to here. So I'm looking at this, and I'm looking at the pass bands, right, of the filters. And these are normalized to FS, right?
Correct.
Well, this is SSM, so this is the slow speed, single data rate, double data rate, and quad data rate. So QSM is the one of interest because this is the one that goes up to 216 kilosamples per second. But
Correct.
look where it rolls off. So that's only like 54 kilosamples per second.
54 kilohertz.
Kilohertz, really. 54 kilohertz. So if you think you're going to run this at 216 and get 100K, receive 100K signals, you're not gonna, because it's just going to roll off and you're only going to get about 50K. Wow. And then, so I went into the data sheet itself. Oops, went the wrong way. So you go back into the numbers and you go back up here. Okay, now where did I go?
What did you just, yeah, I think you're passing it.
Oh, I'm going fast here. Okay, so yeah, so if you go, that's the TDM time. This is I want the acquisition timing. Okay, so right here. I think this is not what I want. I'll find it.
Well, here we are, digital filter characteristics, right?
Here we go. So now,
oh my goodness,
single speed, double speed, quad speed. But look at what they do. The pass band, the pass band is only out to 0.47 or 0.45 or 0.24. Well, that's only 54 kilosamples. I mean, the sample rate is 50. Okay, 54 kilohertz out of 200 sample rate. And then if you look down here, this is bothersome also, is that, where is it? They hold on a second, maybe, yeah, back here. So then I don't know what these are different temperature ranges, but if you look at this, they only specify the dynamic range over 40 kilohertz worth of bandwidth. So this says to me that you're not, if you think you're going to sample at 192K and get 96K because it's Nyquist, it's doubled, I don't think that's going to happen. But right. I'm not an expert on this, so it just jumped out at me like, wow, 0.24 FS.
No, that's not correct. They're cheating. They're not giving you the full bandwidth. They're giving you only half of it.
But that's a filter bandwidth, right? So could you in fact turn the filters off and put your own filters in, or how?
Well, there may be a mode for that, but boy, you really don't want to have to do that.
Why would they do that?
They're giving you this high performance part and then they're crippling it, so I don't know.
That is really bizarre, but because it's showing up in more than one place, there's probably something to it, and you're right.
Well, they say this is automotive. Could it be that they are trying to conform to some automotive manufacturer requirement on being able to tolerate RF in the environment or something?
No, it's more like
usually it's temperature range.
No, I think it's more like they're saying, well, nobody's going to be listening above 40 kilohertz, so why should we reproduce it?
But the difference between commercial and automotive is just temperature range. So this is minus 40 to plus 85.
It's not got to do with the automotive part. What it is compatibility with 192 kilohertz.
Right, but the
sample rate material, but they're not reproducing it all.
But the limitations are the same for commercial and automotive. So that's
that's a red herring. It has nothing to do with automotive. Still, I'm just saying they cheaped out on it and they're not reproducing the full bandwidth of 192 kilohertz. They're just showing compatibility with it.
So why would they sample at 192 kilohertz and only give you 40 kilohertz worth of bandwidth? What's the advantage?
Because there's material available at 192 kilohertz that they want to be able to reproduce, but they're not reproducing the full bandwidth. It's like taking a full HD signal to your TV set, but it's not a full HD set.
So I can watch 4K on my 1080p TV?
Right. Or what's very common on that is it says it will display full HD, you know, the 1920 by 1080, but it's only a 1366 set.
Yeah, or a 720.
It frame converts it. So what they're essentially doing is they're reproducing it, but they're not reproducing the full bandwidth. So yes, if we want to go to 100 kilohertz, we can't use this part.
So I was afraid of.
Yeah.
Well, so
we'll have to look into that.
Well,
you ask Cirrus about that. There may be a mode they can open up, but that looks to me like they cheaped out on the filter there.
And now the filter's an onboard filter, right? Inside the part.
Yes.
Yeah, it's very clear. It's a CIC digital filter inside the part.
Okay, so you can't mess with it then. It's already programmed into the part.
Right.
Yeah, you just look at the graphs and you know what the filter implementation
is. I mean, you can see the CIC here. Let's go down and look at this. This is interesting to point out to people who might not be familiar with this. Okay, if I can go faster here. So when I saw the shapes of the filters, this is probably coming out on your screen. Is really funny, isn't it? Okay, no, so you see this right here?
Yeah, that's a CIC filter.
I mean, that's a CIC filter with the sync function out here. Similar shape of that.
Is that's just your typical FIR filter that you use in this.
Yeah, that's not quite CIC, but obviously an FIR filter.
Yep, and then even at the what's the first one up here? That's the SSM, yeah. So a double
SSM, DSM,
DSM is already a pretty bad filter. And then this one, well, it's reproducing out there, but at very low amplitude. But it's a really
look
filter.
At the TV scale. By the time
I'm looking at that.
It's like yeah. So it's usable maybe out to about
down 10 dB. So well, theoretically you could use it there, but it's down 10 dB at Nyquist.
Right about
0.5.
And then it becomes rapidly unusable out here.
Right.
So.
Yeah, as it's supposed to be. But it's supposed to be gone at half. The other thing that these guys do is they use half band filters that are only down a certain amount at Nyquist and then reproduce stuff above it.
So why do they have a stop band graph here at the 3 speeds, and then up here they have a pass band graph? What is the?
That's showing the micro ripple in it. You'll notice this is 0.02 dB ripple or thereabouts.
Oh, this is ripple. Okay.
Yeah, that shows the ripple within the passband. And then the other is showing you the stop
So this
band.
is just a zoomed in version of these
Correct.
ones down here that show what happens down here.
Right.
Okay.
Well,
I guess we need to maybe look a little further on that one.
yeah.
There are ones that do it for real. Cirrus is one company. The Wolfson is a very good company. Unfortunately, we never did make a really full performance A to D at analog. We did definitely go to 192 kilohertz, but we didn't do the dynamic range.
How about AKM? Are they still around?
I think so.
Because they were the ones that we used for the Janus board. And this is what the red flag came up on this, because there were 3 or 4 chips that Bob McGuire tested to see which ones we wanted to use. And the data sheet specifications were all within a few dB of being identical. So if you look at the data sheet, you could pick any one of them. But what they didn't show you was the noise floor rising above about 30 or 40 kilohertz. So that even though it was designed, I mean, it would sample it at 192K.
Yeah, you have to be very careful about that too, because they will assume that you're not reproducing above that, and they cheat.
Yeah, and the AKM part, when Bob tested it, came out flat all the way up. So that was the part we ended up using. But it's only a single channel and it's very expensive. So.
Hey, don't we have a lot of Janus boards left over?
Yeah, we do. How many do you want? We just, I hate to say this, but when we moved our building, I threw out about 500 Janus board blanks.
Oh, geez.
Because they're not going to build any more of those.
No.
I don't know what to do with them. We didn't throw them out. We recycled them, but we scrapped them.
Yep.
So, sorry to say.
Well, I'm going to say
Jonathan,
73 tonight.
Sorry to rain on that, but I think it's better to find out now than to find out later.
I'm going to do some investigation on the Behringer audio interface that I was showing you the filter plot.
Okay.
And I'm going to look at the data sheet of that part. And I'm going to see what I can see in there as well. And
is that a quad channel part too, the Behringer?
No, that's only 2 channel, and that's a codec that has audio input and output.
Okay.
Yeah, we. And you're looking for what kind of dynamic range? 100 dB, 120 dB.
Ideally 120 dB, but I don't know if, I would achieve that.
Well, we can if we get the right part, but they do get. They're probably going to be 2 channel, not 4 channel.
But typically, though, you can synchronize them together, right? So you can make
correct.
Unit.
Oh yes, absolutely. I mean, they're very much. At least the high-end parts are intended for multi-channel.
Do you recommend looking for something in audio applications, or should I branch out?
This is audio. This is full bandwidth. Yeah, proper 192 kilohertz part will do exactly what you want it to.
All right, because I completely missed this, but I've been inundated with schoolwork, and I really didn't have time to really comb over the data sheet.
Yeah, well, you might also, go right to Cirrus and point this out and say we need one that goes to does full bandwidth at 192 kilohertz. What do you have to recommend?
Okay.
This is the one that we used, I believe, if I remember right.
Mm-hmm. Yep, AKM is a good company too. As I say, I don't know if they're still around too, but Wolfson was really who I considered kind of the best of them.
I think Cirrus bought Wolfson.
Oh, did they?
Yeah.
That's too bad. Doesn't mean they don't have the parts, but they're going to be 2-channel parts.
Where did the parts? I've been having trouble with the DigiKey website and putting prices up.
That's weird.
Because it's sitting here, and if you look down here, it's waiting on the net, and then eventually it comes up, or in this particular case, it just blanks them. So maybe this part's not in production anymore because it doesn't show how many they've got in stock. Yeah, so this may be obsolete now. I know that Tapper bought a whole bunch of them. We ended up selling them to Flex back when they were using them in their radio. I forget which radio. Use one of their mixer type radios. They use this part. So we sold the rest of our stock to them.
Yeah, standard package, 1,000 parts.
Yeah, a reel, right?
You're gonna have to buy the whole reel.
And they're $50 each, and it's 300 parts on a reel. Yeah. So you go like, oh, 15 grand for one reel, not bad.
Okay, DigiKey, let's see how good you are at this. I just clicked, show similar.
Oh, to the 5394?
Yeah. No.
Then it gives you a 7404, right? Something totally irrelevant.
Yeah.
Yeah.
Some 12-bit parts.
Yeah.
Let's see. Huh.
But you know, it's thinking about this. When we did this, this was, I think, Dave, correct me if I'm wrong, it was 14 years ago.
Yeah.
That we built the Janus, 2006.
Yeah. Well, that's how long I've been out of analog.
Well, you know, I find it interesting that at our company, we did a lot of SDR work. And so we would get the analog devices guys in, or we get the linear tech guys in, or the TI guys, or whoever it was hawking stuff that day. So when the linear tech guys are in, I asked them once probably in 2015 or 16. So about 5 years ago, but still 10 years after we built Mercury and Hermes. And I said, okay, it's 10 years later. What A to D would you use now if you wanted to do a state-of-the-art version of the Mercury board? Because I just finished describing the Mercury to them. And they came back and they said 2208. Same part.
Same part.
And I said, well, you know, 10 years, you haven't come up with anything better? And they kind of admitted sheepishly that they've been trying to get better full-scale dynamic range and lower noise for the past 10 years, and they have not been able to do it on a 16-bit ADC. So, so 2208, that's the one. Even today, I guess it's still a very big contender.
Well, at some point, you're just limited by the physics.
Yeah.
Yep.
It's like you need to get the government involved so they can handle changing the laws for you.
So Cirrus does have the Wolfson parts.
So did they get bought by Cirrus then? So they
apparently.
How long ago? Do you know, Jonathan?
How long ago? What?
How long ago did Wolfson get bought out?
Oh, I think it was a couple of years ago.
Oh, recently.
Maybe 2015 or something.
Here you go. What's the date on this one on Google? It's April 29th, 2014.
2014.
Cirrus Logic agrees to acquire Wolfson. That doesn't mean it happened then. That's when they agreed to it. So then add 2 years to it for SEC nonsense, and maybe that's when it happened.
Yep.
This is interesting.
My digital voice recorder that I use to record VLF in the field, that used a Wolfson Micro A-to-D converter, and that was also an idea that I had in mind, but I was looking at what they had currently, and it seemed like that there were a lot of features that I would not even use. So at the time, it didn't make sense, but I'll have to take a look at this a little bit more.
But that's okay. Features that you don't use, just sit there. If it has features that you do use that are high performance, it's sometimes worth it to just, buy it for the features you need and just ignore the other ones. Except that you're going to pay for it, even though you don't want it. Like the codec, you're going to pay for the coding part that you don't want, but oh well.
Well, right, and in the I think in the Behringer audio interface, some of the functions are not used.
Hey, I don't think you're ever going to get better than this 5394 because look, it's a super high performance ADC. I mean, come on now, how can you beat a super? So what do you have to have? What's after super? It's
Super duper.
Extremely, right? Oh, yeah. Super duper.
Yeah. Hyper.
So it's VHF, high frequency, very high frequency, ultra high frequency, super high frequency, extremely high frequency, and then I don't know what comes after that. So this would be extremely high performance ADC would be the next level up, right?
Guys, I'm going to say 73.
All right.
Talk to you next week.
Good idea.
Yeah, I think that's a good idea.
Enjoyed it. 73.
Yeah, I think so too.
We'll be in touch.
Thanks for spotting that, Scotty. That's like, oh my goodness.
Well,
that's a killer.
Yeah, I was hoping it wasn't true. But
no, you're right. Well, I know there are ones that do it right, but it may take a little searching at this point.
Yeah. Okay, well, 7-3, everyone. Thanks for looking at this and affirming my worst fears.
Well, more shall be revealed.
So, all right. Nathaniel, you want to leave it back on so I can chat with Dan?
I will be glad to.
Por favor.
Yeah. Absolutely. So let's see.
All
right.
We got off last time, and then Dan texted me and told me we could reconnect, but I never did. So.
Yeah.
If you guys have some parts that you're looking at, let me know.
Okay. Yeah, you can read the data with a more experienced eye and find stuff that you miss.
Yeah, I think you can just use this link whenever. So it's just kind of always open.
Unless something else is going on that you have. Right?
No, I don't think that's true, actually.
Oh.
This is specifically Tangerine?
Yeah, I have a scheduled meeting for this Tangerine SDR every Monday night, and I have the allow people to join before the host enabled, and yeah, I'm pretty sure you can just join in even if I'm on another call.
I think you can. It just joins to an empty room.
Yeah, but yeah, people can chat and stuff, so I don't know. But yeah, no, I'm pretty sure. So yes, I will make you the host, Scotty, and I will talk to you later.
Okay.
And yeah, I tend to be a lot more lively for the Thursday morning meetings, don't I? I'm sorry, Monday nights I just like glaze over.
And Thursday morning you notice I'm like mostly asleep.
Yeah, so I guess we're kind of like out of phase there.
Yeah.
Thursday morning I've got my coffee. I'm usually much better. All right. Yeah, thank you very much. And yeah, thanks for catching that on that part. So hopefully we can find a better part.
All right.
Okay. 7-3.
73.
7-3.
7-3.
Well, I guess I should stop sharing my screen now.
Oh, there we go. Good deal.
Get rid of the super high performance ADC.
Yes. Yeah, I may have kind of limited shelf life tonight. I didn't really I didn't actually sleep last night.
Oh,
I
how do you work when you haven't slept?
well, I didn't actually work much today. Today is actually my birthday.
Oh, happy birthday.
Hey, thanks.
39 again, right?
Yeah, again, for the 33rd time or whatever.
So here, check out this new flashlight I got.
All right.
This is 2300 lumens.
Wow.
If I can get it to work here.
Does it flash automatically, or is that just an aberration?
This destroys my camera.
Oh yeah.
I don't know if you can see. I'll shut it. No, that'll blind you.
Yes.
Anyway,
Wow.
it's
like
it's so bright the head gets hot to the touch, so you can't hold on to it.
So does that mean if you put it behind your head, you'll be able to see all the way through?
I think if I went like this, you could see through that way.
Like a nuclear explosion.
And then I got this really cool copper billet flashlight.
Oh.
I've gone
it's
crazy.
actually hogged out a billet? Is that
It's a solid. Well, it's the cap piece is separate from the middle piece, but it's a solid. It's not plated. It's solid copper.
I'll be darned.
And then I got this one, which is pretty cool because it's a right angle one.
Oh yeah.
So I got a strap, a headband that mounts it up here. So, and it's like 500 lumens. So it's like 3 times stronger than my strongest headlight for working on the car and things like that.
Yeah, that's nice.
And then like for ham flea markets, you've got
for early in the morning before the sun comes up.
Because that's going to be if they ever start having them again.
Yeah.
So wintertime's the time you need that. Summer you don't.
Yeah, that's a big if, I think.
And I guess I could put it on my helmet too. I could strap it on my helmet and use it as a bike light. Because it's much stronger than I think my bike light's 120 lumens or something, which is pretty good, but not for modern lights. I mean,
yeah, I think mine was like next generation. It was about 200 lumens.
Yeah, mine's that minute, the little bitty thing about that big.
Yeah. Yes. Yeah.
And yours was brighter than mine. I remember that. And it was.
Yeah, I just bought mine like a few months later. That was the big difference.
So, still haven't gone biking though.
Well, I have ridden a little bit, not much.
Has it gotten cold there yet?
It's been chilly the last couple of days, but we have another tropical storm system coming through later in the week.
Oh, that's right.
So it's going to be up into the 80s.
Well, isn't that tropical depression? Did that turn into a hurricane?
Yeah, it's a Category 1 now. It's
not supposed to get
any stronger than that. Yeah, it's actually right on the just north of the Yucatan.
Yeah, well, it's been sitting there stationary. It's been sitting there stationary for like 2 days.
Yeah, they tend to go there and die. I was actually in what the hell's the name of it? Playa del Carmen, which is on the Yucatan Peninsula. It's south of Cancun, about 50 miles or so. And I was there one time when a hurricane came through, and the hurricane actually came on shore and then just spun for like maybe 4 or 5 days.
Oh, God.
About 100 miles inland.
And then just soaking everything immensely,
exactly.
Right?
Yes.
Well, was it Ivan that came in and it went across? It came up across Cuba, inland, turned around and went west across Florida, and then came back up and went north into the mainland. It hit the continent twice.
Yeah, I'm not sure if that was Ivan, but I do remember one of them.
And wasn't that the one that went all the way up into Ohio?
It could be, yes.
Because it went directly north. And I mean, it wasn't much wind by that time, but it was just a ton of rain.
Yeah, I remember when I was a kid, we would get like hurricanes in Ohio, or the remnants, not actually the hurricane, but a low pressure system coming through. About once every 2 or 3 years, it would have one come rolling by. They were big weather events for that area because of all the rain.
Yeah. Well, the hurricane season is pretty much over now, isn't it?
It goes until the end of November, believe it or not.
Oh, really?
Officially. But it's the peak part of it is over now. But it's still, there's still stuff that happens out there.
Well, it's 70 knots. I was going to say 70 miles per hour is not even a hurricane, but it's 80 miles per hour.
Yeah, 70 knots is about
80.
83 miles an hour, something like that.
And what the category 1 starts at 74 miles an hour.
Yeah, yeah. Yeah, I'm not sure why they do those. And the whole thing between using statute miles, nautical miles, knots, miles per hour, it's all very confusing, and it really shouldn't be.
Yeah. Furlongs per fortnight.
Yeah, yeah, exactly.
Might as well do that if you're going to do all these other. Yeah. So I bet you're going to get some rain because it looks like it's going to go right up to the west of you.
It's raining right now.
Oh, it is?
Yeah. Not too hard, but it's raining a little bit.
Okay, where's the satellite images? I don't see any. They hide this stuff on these pages.
Yeah, I'm not sure where my
satellite. There it is.
Weather. Welcome to the weather.
So
okay,
this is, oh my God, that's pretty big. Oh
yeah,
no,
so
it is. It zoomed in. It zoomed in, so
Oh.
it's not as big. It's gonna say it's like, wow, look how big. Well, and then you look and you see
it's
that
not unusual. I mean, for a system to do pretty much the whole Gulf of Mexico.
Yeah.
I mean, it may not be real intense.
But this is only about as wide as the Yucatan Peninsula is wide, which is not very.
Yeah. Yeah, and the Yucatan is relatively flat, so it doesn't do much to knock down the storm. If you move a little bit further west, it's a little more mountainous.
Yeah. Well, it's interesting because when it was a tropical, not a tropical depression, but it was forming. So I don't know what you call those before it's actually formed into a depression.
Yeah.
But it was moving zero. It was stationary.
Oh, yeah.
And just sitting right about where it is now, just churning. Now it's moving 12 miles an hour north. So a couple days you'll get it.
Yep. Undoubtedly.
Yeah, great, huh?
Yep. Yeah, I'm actually, I use lightningmaps.org for weather radar. It seems to be a little bit better for whatever reasons.
I'm looking at the whole hemisphere weather radar. Doesn't look like, oh yeah, it does look cloudy where you are.
Yep.
Man, it's cloudy over most of the U.S. It's been cloudy here. It's it only got up to 70 today or so.
You're kidding.
And it was like 90 yesterday. It's like boom, somebody turned the switch off. There goes the heat. Yeah, it's amazing. Let's see, where is my forecast here? Yeah, it's going to be 46 tonight. This is the first time it got below 50.
Wow.
This summer, this fall.
It's actually warmer here.
Well, it's 61 right now, but it's going to be 46 for the low.
Yeah, I'm not sure what it is right now. It's probably in the 50s someplace.
But all of that said, by Sunday it'll be 90 again. So it's can't win here. But let's just say that the air conditioner is not running much these days.
Well, that's a good thing.
That's a good thing, yeah.
So how's the house coming along?
Stalled.
Stalled?
I tried to fire my architect, but my contractor's telling me that it's not really practical to do that at this late of a date.
So your contractor's saying, hold on, just hang in there, it'll get better.
There's not anything we can do because, okay, so he told us we were into the city, and then now he's telling us we're into FEMA. Well, we've been into FEMA for a month.
Yeah.
And see, the trick is I used a different credit card to pay the FEMA fees. So, and I have not seen the charge come in on that card yet. So I know that they haven't looked at it and issued the permit.
Well, I think right now the government's pretty much in stalled action. I mean, they're not doing a damn thing.
Well, we turned it in over a month ago and they haven't done anything.
But a month in government time is nothing.
I was hoping to break ground
it's like
by
15
December,
minutes.
but I'm not thinking I'm going to break ground ever at the rate we're going.
Well, yeah, it'll eventually happen, I'm sure. But
the good news is that Steve Kafka, one of the Explorer Post guys, is going to sell me his 20-foot container. So we're going to have on-site storage coming up here pretty quick.
Good deal.
So, and I'm thinking of buying another one.
Are there places to buy those around Phoenix?
Oh yeah, a couple good places. So we'll see what I've actually put in a request for a quote, see what I can get for a 20-foot one. So I'd have two 20-foot ones. I put them in the corners of the property.
Yeah.
And I use them as fences. Well, I want to put them behind the building so they don't block the view.
Yeah.
So we'll see what happens. He wants to sell the thing for $1,000, which is pretty good price, I think. I bet it'll cost at least half of that just to move it.
Probably
you gotta
so.
get it. Have you ever heard of a road doll?
No.
ROADOLL?
No.
It's the way they move the 20-foot and smaller ones. They basically winch them up onto the back of a tilting flatbed. And then they get to your place, they back in, and then they tilt the thing down until the container hits the ground, and then they
pull off of it.
And it just sits it on the ground.
Yeah.
So, but it weighs 5,500 pounds empty. Little light guy, huh? 2.5 tons.
They have like container companies that move stuff, and they have they dropped one off here maybe 6 months ago.
Yeah.
And they've got like this very specialized hauler for doing it.
Yeah, that's what this is. They call it a road doll.
Is that what it is?
Yeah, and I've been to a couple of 3 different ones who advertise moving.
Oh, okay.
And the road dolls are used for the smaller ones. If you need a bigger one or you need to set it in a restricted space, then you have to get a crane to do it, and that's much more expensive. But the thing is, a 40-foot unit requires 135 feet of space because the truck has got to back in and then slide it off. The truck's got to be able to go forward about 90 feet to drop the container off. I mean, the length of the truck plus the length of the container plus the length of the container, that's what it needs.
Well, this deal was much more precise than that, and it worked in a very small area.
Was it a crane thing?
Yeah, it was. Let me think about this.
Because these are all just slide-off things.
Yeah, it was not a slide-off deal. It actually lifted the container up, and then swung it around, and then dropped it down. So it was more of, I have to think about it a little bit because it's been a while. I've kind of forgotten exactly how it worked, but I know that the guy was able to place it very precisely, and it was really not a roll-off deal because they put them in parking lots, usually within a parking space. So they have to kind of work within the parameters of the parking lot.
They can come in at night when there's no cars in there, right?
Well, around here, it's more cars at night than it is during the day.
Oh, okay.
during the day, I mean, it's about half full, and then at night it's completely full. Yeah, with an office place, it would be just the opposite, but with residential stuff, it's a lot busier at night than during the day. Although that's not necessarily been the case lately.
So did you see that Jonathan put a new
I saw that. I just looked at it.
But this thing, this 4272 has the same limitation as the other one.
Huh.
0.24 FS in quad speed mode.
Yeah.
Right, that's the one that's used in the Behringer 404.
Is that the one you have the plots for?
Yeah.
Huh. Well, David seems to think that this is a limitation, so I would go with him because I don't know. So
originally when I picked this part, I didn't even think about going up to 100 kilohertz because most of what I do is in natural radio, and I was hoping that this would satisfy other parties, but it apparently does not.
What frequency range do you need for your VLF for your lightning stuff?
Well, I only really need to go up to like 30 or 40 kilohertz max. I could really stay within the audio range, and that would cover everything I need. But other people wanted higher frequencies. I would imagine for primarily for the VLF transmitters that are in the upper VLF band. So, and those VLF transmitters, they're very low bandwidth anyway, and that's why that I figured I could get away with that. But I don't know. That would be something that would be up for more discussion. But I'll just have to try to see if I could find another part, maybe. Bill Lyles, one of the academic people that works with a lot of the VLF stuff, he recommended an ADD converter from a linear it was like $24 a piece. It was really expensive.
Single channel?
Yeah, single channel.
Sounds like the AKM part. So you really couldn't afford to put 3 or 4 channels on the board, right?
Right. Yeah, I mean, that'd be like $100 just in ADD converters, and then there's the cost of the board. So, I'm sure that it would perform, but I need at least 3 channels, minimum 3.
Yeah, because you need you need 2 azimuths in horizontal polarization and 1 in vertical, right? In omnidirectional.
Yep.
You need 3. Well,
yeah, this might be a lot more difficult than I thought that it would be.
Yeah, usually is, especially if it starts out simple like this. The magnetometer ended up being way more effort than I thought it was going to be for something so simple.
Yeah. And honestly, though, I personally see the research value with something like um, with VLF in the audio range, but other people mostly are interested in the VLF transmitters. So I don't know if I don't know. It's hard to say.
Well, just a matter of finding the right one.
Yeah, I think that's going to be a challenge. I have a take-home test from Nathaniel's class, so I'm going to focus on that for this week. But next week I'm going to see if I could find something a little bit something that would work and satisfy everybody. And the majority of the sound cards, at least, so Paul writes the software, and it's for mostly sound cards, and the majority of the sound cards seem to have the same kind of performance, and they do tend to roll off once you get to the upper part of the band, but I don't know. It's probably something that I'll have to look more, discuss with Nathaniel, and discuss with Bill, and we'll talk about a cost, what cost is acceptable, because I think that's what it's going to come down to. It's going to come down to cost with this thing.
Yeah, it's like kind of like David says, you can go as fast as you want. How much money do you have?
Right. Yeah, and I'm sure that I can get the performance that they want as well, but I don't know for how much and how much they'd be willing to pay. What I wanted to do was I wanted to make this somewhat graspable in terms of cost, but I really don't know. Because I would imagine that since our hearing range doesn't really go beyond 20, 30 kilohertz, I would imagine Sirius just kind of doesn't really care much about what happens past 40 kilohertz.
Yeah.
I would imagine.
Which is why they limit the bandwidth, the dynamic range measurements to 40 kilohertz.
Yeah. And I don't know if you could turn the digital filter on or off with a register.
Well, so this is interesting. Here's a TI one. It's a 24-bit, 512K samples per second. It's an ADS 127. Oh, but that's going to be too expensive too, probably, because in hundreds it's $12, and it's a single channel.
Mm.
So that's half the cost of your other one. Okay, so it's got a signal to noise ratio of up to 115.5 dB, so it's higher than the Cirrus one. Passband up to 230 kilohertz because it samples at 512. 24-bit. And they have some different digital filter options. But it's expensive. Let's see.
And that's quad channel?
No, it's one channel.
Oh, one channel.
I think it's one channel. It's one channel, yeah.
Okay.
But it's $12 in hundreds, $11.37. So.
Oh. Because I was looking at TI and they had a couple different multi-channel parts, and they were all newer. It wasn't anything from Burr Brown. It was their newer stuff, and
yeah. So let's see. Okay, so here's a 4-input one that will go at 256K. It's $21. Another 4-input one that goes at 256K. It's $21. It's the same one. And then there's a third one. These are all analog devices. And yeah, so it's 3 256K ones. They're all between 15 and $20. How much was that Cirrus part?
it was $12 on DigiKey.
Okay. Because here's one that is a 1.5 megahertz clock. And it is 4 channels. Ooh, $32. It's a analog devices AD7134. 108 dB of dynamic range at 374K. It's 137 dB at 10 samples per second. Okay, that's right.
David just emailed me or the tapper list. So he found an AKM 4-channel part. Can sample up to 768 kHz.
Okay, what's the number?
Let's see. The AK5574.
AK5574. DigiKey wrecked their website.
Yeah.
It's slower than dog meat. It has been for the past week. It's a 32-bit one.
Yeah.
121 dB dynamic range. Here you go, 4-channel A to D. What has a TDM 126, whatever that means, for the interface? See, it has PCM mode, DSD mode, or I'm trying to figure out how you get the data out of it. You know how?
Oh, so
3-wire serial I2C.
I think DSD mode. I think that has something to do with those extended those, like, I don't know if you've ever heard of them, those super audio CDs.
Oh yeah, the SACD.
Yeah.
Yeah, the high definition audio.
Mm-hmm.
I have one or two of those, but I don't have anything that will play them, so it's kind of pointless.
Yeah. I think this might be, it might be one of those A to Ds that are used to record that.
Oh, okay. That would make sense. Okay, here's the ADC filter characteristics. There you go, stop band, minimum 640 kilohertz. Wow. This will do 384K.
Yep.
It'll do 512K. What is the sample rate? Yeah. I'm looking for that same kind of spec that I found on the other one with the filter limitations on it. I don't see it.
So for, are you looking on, what was it, page 14? The ADC filter characteristics for 192 kilohertz.
This is on the AKM part?
Yeah.
Oh, I see on 13.
Or,
a short delay, slow roll off, sharp roll off at sample rate 96K, and it goes to 40, just under 48K. But where are the higher? Yeah, okay, so yeah, so if you look at the sharp roll off on page 15,
yeah,
it goes above 112 kilohertz.
Yeah, yeah.
The ripple looks terrible, but that's only like 0.01 dB per increment. So it's, I think it's ludicrous that they boost the scale up so high to make it look like there's ripple, but there really, I mean, there isn't any.
Right, yeah.
Yeah, I think this one might work.
I think so. You know, David said that he was an applications engineer, and that's honestly, that's the career move that I want. I've always wanted to work in applications.
So attach yourself to him and learn everything that he knows.
Yeah, yep.
That's the cool part about working on projects like this is you find people who are really experts in their field. And while, you know, I've been around for a while, I know my field pretty well. There's lots of things that I don't know as well as I want to. And there's experts on here that know that stuff. So, okay, here you go. 960 in hundreds. The AK-5574, under $10. Cheaper than the Cirrus part.
Yeah. Yeah. This is, I'll tell you, yeah, this is a really nice substitute.
Okay, so now, how do we get the data out of it?
Okay, so
it looks like it's got master mode and slave mode, just like the other one did. M clock, LR clock, and BICK. What does that mean?
So
LR clock's left, right. Oh, so
yeah.
maybe BI clock is even odd or something like that. So it's basically a 2-bit spot.
TDM in.
That's PCM.
Let me look at the pin functions here. So so the BI clock, audio serial data clock input pin in PCM and slave mode, or it's so BI clock. So we probably will not be using DSD mode, but that might lock us out on certain sampling rates. I don't know.
Okay, so LR clock is channel clock. What was the other one I was looking for? BI clock. You said what it was, I think, but I didn't.
So the BI clock.
Serial data clock input.
Yeah.
Okay, so that's just the interface clock. So it's BI clock is the clock input, and LR clock is the left-right select.
Yep.
And then there's got to be a data pin somewhere. TDM data input. There you go. DSDOR1, audio serial data output. In DSD mode. Okay, and now I'm going to have to read what DSD mode is. Yeah, but it's got SDTO1 and SDTO2, so it looks to me like that, you know, a lot of these timing numbers look the same as that Cirrus part. You know, 64FS, because I think it's a 64, it's a 6-bit sample and hold. So they sample it 64 times before they get an answer out. So that means that the clock has to be 64x, whatever the conversion clock is.
Yeah.
Only this data sheet's even longer than the other one, 70 pages. This looks like a really good spec part, though, if it really works like this. Okay, now the next part, next thing we're going to do is we're going to look for an evaluation board for it.
There is an evaluation manual.
So there must be a board then, right?
Yeah. AKD 55x4
AKD 55x4.
Yep. It's AKD 55x4-B for board.
I see manuals, but I don't see where to buy the board. Probably have to buy it directly from AKM. Not at DigiKey, you won't.
Oh.
Here we go. Evaluation Board Rev 3 from Seacorn. How much does it cost? It's in Chinglish. Who knows how much it cost? There's a picture of it, but no cost. It's all in Chinese letters. I can't read what it says.
Oh.
There you go. There's the evaluation board manual. Okay, so it's got 4 analog inputs, and it's got a, I don't know what an AK4118 is. It says DIT, D-I-T.
That must be Burr Brown's digital audio interface.
Huh. It is a, what is it? It's a 24-bit digital audio IF transceiver.
Yeah.
It's up to 8 inputs and gives you a couple of outputs.
Yep.
Yep.
So yeah, that's I think it allows it converts I2S or something like that to SPDIF and back. I know that's what those ICs do. So that's probably on the output, I think.
So it talks about DIT like I should know what it is. Well, anyway, I'm sure we can make it work. Just have to make sure I give you enough I/O pins.
Can you post the link in the chat for this evaluation board that you're looking at?
Sure. Well, I found it on a yeah, this is some Chinese website. There you go.
Okay.
So we putting you to sleep yet, Dan?
Say what?
We putting you to sleep yet?
No, but I had to put on my pajamas.
Well, you got to get ready for bed.
Yeah, just in case I conk out midstream. I don't want to be fully dressed when that happens.
Your head hits the table.
That's right.
Oh, I know what that is.
What?
Yeah, that converts I2S to SPDIF.
Oh, okay.
The one that I was looking at, I think this might be a newer version.
I think this looks like a good choice.
Yeah. Yeah, it might give the performance that they're looking for.
board. We never found out how much the board cost, though, did we?
No, that I'm going to have to look up, and I'm going to have to check on that.
Okay, let's see. There's got to be a way to buy this thing without going to China. Manuals, 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 manuals. Arrow, there you go. You ought to be able to buy from there. Well, that's interesting. I put the number in and Arrow comes up with an AK-7755.
Oh.
I don't know what that part is. Okay, let's see. 24 bits, I2C, single channel. Maybe it's a single channel version of the 5574.
Could be. So I'm posting the link now to the AKM site direct. So it has an evaluation board manual. That's the one that I was looking at.
Just tell you where to get it.
Probably not. So according to the ordering guide, let's see. So the AKD 55X4.
Maybe you have to roll your own.
God, I hope not.
See, the other bummer about this part is it's a QFN package, and I hate soldering those.
Yeah, I hate soldering those too. Oh, look, it's a schematic of the board.
Yeah, plus Gerbers. Plus Gerbers. Plus the hole locator drawing. So I think this is one where somebody must make this.
See, with so with images of these individual layers, can these be imported into like PCB layout programs? And as long as you pick a specific scale, it'll create properly scaled Gerber outputs for you.
Well, you can't take them off this PDF, but if you could get Gerbers, real Gerbers, you can just make the boards.
Well, I mean, let's say that they don't want to give them to you.
Board. So what you're saying is you make your own debug board and buy one? Oh. I got to stand up here for a minute.
The board looks like it's pricey with the size of it.
Sometimes you'd be surprised because they want you to use their part. So they price it accordingly.
Oh.
They're subsidized, in other words.
Oh, I see. Okay. Because the fab house that I usually send all my boards to is OSH Park, and they make beautiful boards. The only drawback is that as you go up in the area, that the price goes up drastically. But if you want to make really tiny boards, you could do that and pay only like a couple dollars, including shipping, if the board is small enough.
Yeah. Well, I don't see where you can buy this, so.
Probably something that we would have to contact AKM for.
Yeah, yeah, and you may be able to get it directly from them. In fact, that is a good question. Products. What was that board? Is that say A to D? 4-channel, let's see, 55, yeah, 4-channel differential 32-bit Delta Sigma ADC. Okay, 5574. 5552. Okay, how come there aren't any? Ah, because they're not in order, that's why. I hate that. Ever heard of velvet sound?
Yeah, I was wondering what that meant.
I think that maybe is a manufacturer that uses this part in one of their products.
Oh.
Evaluation board manual right on their webpage. But how do I buy one? I have to go to the, see, technical resources. I forget who the rep is. Well, here's an inquiries link.
Yeah.
To purchase a product or sample, ask technical questions, request a product information, please fill in the following form and send it in to us. So there you go. Tell them you're a student, you're working on a project that's going to sell thousands of these. Maybe they'll give you a free board.
Okay.
Purchase product or sample. Oh, here we go. Who's the rep? They got DigiKey. They don't have any boards.
They may be able to, like, I might be able to get the.
Here you go. Arrow is the distributor. So let's see if we can find one at Arrow. What's that again? AKD55X4?
AKD 55X4-B.
It's B. No results. AKD55X4-B. Yeah, I searched for it properly. Well, let's search for the chip. and see if they have that at least. They do, in fact, have the chip. And their price is how mucho? Get a quote. No stock. Ask for quote. Okay. I think I've had enough fun for today, but I think we got a good candidate here.
Yeah.
So you want to go ahead and contact them and see what they say?
Yeah, I'm gonna. I will contact them either this week or next week, and I'll see what they say. And
but if you're busy, you can just drop them a link on their webpage, and if it takes them a week to get back to you, that's no problem because you're busy anyway. So
yeah.
Okay, so
Sounds good.
7-3.
All right, 7-3, everybody.
Stay warm out there.
Okay. I'll talk to you later, Scotty.
Okay. Bye now.
Have a good night.